Case 1. Horsens combined heat and power plants is described in the following video by Group D. Horsens power plants consist of one steam turbine which produces an output of 12,500 kW and one gas turbine which produces an output of 21,000 kW. The steam is produced in two large boilers which burns trash. The annual power production is 150 GWh per year, and the annual district heating production is 1000 TJ. The annual waste consumption is 80,000 tons. The inlet steam temperature is 420 degrees and the pressure is 45 bars. After the steam turbine, the temperature is 100 to 150 degrees and the pressure is 1 bar. The normal speed of the turbine is 10,500 RPM. The critical speed for the high pressure fans is 4,530 RPM, and for the low pressure fans the critical speed is 5,700 RPM. When the fans reach the critical speed, the turbine starts to resonate, which can cause damage to the turbine. The picture below shows the startup procedure step by step, which takes about 35 minutes. A steam turbine converts thermal energy to mechanical energy. The mechanical energy is absorbed by rotating a generator that produces energy. The unexploited waste heat from the turbine is leaked through a district heat exchanger. The energy conversion is done by two different types of turbine blades. The first type of blades are called fixed blades and are used to convert some of the steam's enthalpy to kinetic energy by increasing the velocity of the steam. The fixed blades are mounted on the housing of the turbine. The second type of blades are called rotating blades because they are attached to the rotator of the turbine. The steam hits the blades and thereby force the rotator to turn. As the energy progressively converts throughout the turbine, the steam expands as the pressure lowers. By letting the turbine increases with the expansion of the steam, the energy is optimally exploited. The central control panel is located at the control room at the throughout push buttons activates the combined stop emergency valve. This sends the steam to the 4 steam control valve and 1 extra bypass valve for safety reasons. The Allen electronic governing system manages the steam to the nozzle jets in the high pressure turbine. The steam is exhausted into the low pressure turbine, and when the energy has been used in the low pressure system, it is let into the condensers, a high pressure and a low pressure condenser. Shows the 3 boilers. All of them produce steam. The steam is first let into the high pressure part of the turbine. When the steam has delivered its energy to that part of the turbine, it is let into the low pressure part. Some of the remaining steam is let from the low pressure turbine on the heat exchangers for the district water. The rest of the steam is possible to direct to a preheater for the boiler water.
To summarize this presentation, we want to show a general animation that shows how the steam turbine works. As you can see from this animation, the steam from the boiler is leaked into the turbine, where the steam makes the turbine rotate. The rotator is connected to the generator shaft, where the energy is transformed to electricity. When the steam is passed through the turbine, it is leaked into the condenser, where it is transformed into water again.